Welcome to ilectureonline. Now let's take a look and answer the question, what is matter? Because we decided in the first video that the universe is primarily made of matter and energy. So what is matter? Well, we already know that 99% of all the matter in the universe is either hydrogen or helium. It turns out that hydrogen makes up about 75% of the whole universe, and helium makes up about 25% of the whole universe. They add up to 100%, of course, but that's not quite the totality of all the matter in the universe. Together, hydrogen and helium is about 99% of the total mass. The other 1% is everything else on the periodic table, such as lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, and so forth. If you open up a periodic table, look at it, there's over 100 elements on that periodic table, all made up of, well, nuclei, something that makes up the nucleus of each atom, and the electrons which go around the nucleus. And if you take a look at an atom a little bit closer, and you look at the nucleus of an atom, you will realize that a nucleus is typically made up of protons, which I've delineated here by a little plus sign because they're positively charged, and neutrons, the little circles with a little n in there for neutron, because they're neutral, they don't have a charge. And then the electrons are notated with a little negative sign because they're negatively charged. So every atom is typically made up of a nucleus, which consists of protons and neutrons, and electrons going around it. The one exception is hydrogen, which only has a single nucleon. A nucleon is a nuclear particle, which is a proton in the center and one electron going around it. So hydrogen is the only atom in the universe that does not have a neutron. Although there are some what we call isotopes of hydrogen that do have a neutron, so there will be one proton and one neutron in the nucleus, but that's relatively rare compared to most hydrogen in the universe. The hydrogen that makes up the stars, and notice there's a lot of hydrogen in the universe. Imagine 3/4 of the matter in the universe is hydrogen, and 1/4 is helium, and together they form up almost all of the matter in the universe. So, what is an atom? What is matter? How does that work? Well, it turns out that the nuclei of atoms, and it turns out what sets one element apart from the next element on the periodic table is the number of protons in the nucleus. Notice that hydrogen has 1 proton, helium has 2 protons, lithium has 3 protons, beryllium has 4 protons, boron has 5, carbon has 6, nitrogen has 7, oxygen has 8, fluorine has 9 protons, and neon has 10 protons. So what makes one element different from the next is simply the number of protons in the nucleus. And it's amazing how different an element can be by simply adding 1 proton or taking 1 proton away. For example, lead, which has the chemical form of Pb, has 82 protons in the nucleus, and gold, which is Au for aurorum, comes from the Latin word aurorum, has 79 protons. And back in the days of the Middle Ages, when people that were called alchemists knew what gold was and knew what lead was, and there was a lot of similarity between those two metals. They were both soft, they were both very heavy, and they thought they could actually turn lead into gold. Imagine if you could turn lead into gold. There was lots of lead around, there wasn't a lot of gold around, and so people for many years tried to turn lead into gold. Of course, they didn't realize that it all came down to the small nucleus inside of each single atom, where every lead atom simply had 3 more protons than every gold atom, and so to turn lead into gold, you would have to remove 3 protons from every nucleus. There was no chemical reaction that could possibly make that happen, and so the attempt of turning lead into gold, of course, was a futile attempt. But it is interesting how matter just changes from one type to a very different type, from one element to a very different element, by simply changing the number of protons in the nucleus. Now, what's also interesting is that atoms actually take up quite a bit of volume. You say, really, are you kidding me? Atoms, aren't they those very, very tiny little things? And yes, atoms are extremely small. But if you take a look at an atom and you realize that there's a nucleus at the center and you have electrons going around it, the nucleus actually serves as has several purposes. For one, almost all the mass of matter is concentrated in the nucleus. More than 99.9% of the mass of an atom is concentrated in the nucleus, and the electrons form up less than 0.1% of the mass is in the electrons. However, the volume of the nucleus is extremely small. It's very, very tiny. As opposed to the size of an atom, it's actually quite large in comparison. That's because the electrons are so far away from the nuclei to give the atom's volume. The way the electrons give an atom volume is by zipping around the nucleus at a very high speed. Notice that the nucleus is positively charged and the electrons are negatively charged. And if the electrons weren't moving, they would simply collide with the nucleus, form one ball, and the atom would basically disappear. Well, it wouldn't disappear, it would cease to exist as an atom. What gives an atom its volume is the electrons zipping around the nucleus at very high velocities. It turns out that the electrons, in order to prevent from being captured by the nucleus, they have to travel so fast that the centripetal forces cause the electrons to stay out there in orbit. And so what happens then is that the distance from the electron to nucleus is absolutely enormous. So what would be a good way to think about it? Well, let's say that if the nucleus was like the size of a basketball, the electrons would be 5 miles away. So let's say here's the nucleus of an atom, and the electrons would be 5 miles away, zipping around the nucleus about 6,000 trillion times per second. The electrons travel around the nucleus so fast that they're basically everywhere at the same time, and those electrons whirling around the nucleus basically form a hard shell of existence around the nucleus, giving it volume. And so matter, even though it's in a very dense state, the nuclei is very dense and very tiny, matter is typically made of the orbitals of the electrons zipping around the nucleus at very high speeds, kind of forming these hard shells. And so when you have matter set next to each other, it's basically the orbits of the electrons that keep the orbits of the other electron from overlapping, causing the atoms to have volume like that. And so matter is made up of nuclei with protons and neutrons, and electrons zipping around at very high velocities, giving it that shell-like structure, causing matter to take up volume. Without this way of composition for an atom, atoms wouldn't really exist and the universe wouldn't really exist. We owe the existence of the universe to the fact that atoms are structured like that. Very interesting. So that is what makes up the universe. Again, the predominant matter is hydrogen and helium, but of course we know on the Earth there's a lot of other elements that make up a lot of other things. Planets and moons tend to contain all those various other elements, and it turns out our sun, which is 99% hydrogen and helium, about 1% is also all the other elements on the periodic table. So there's some relationship between our sun having terrestrial planets and our sun containing the very elements that our Earth and the terrestrial planets and moons are made out of. So that gives us kind of a clue of how the universe is made up, how the material in the universe is made up. So that's the answer to the question, what is matter? So if you're still interested, take a look at the next video and see what we have in store for you.